Hello everybody. So this is the second lecture on pointer. On the last video lecture we discussed that what is the basics of pointers, and we also discussed that we define pointer to store the address of a variable. Now the pointer will store the same amount of memory location, pointer will reserve same amount of memory location in order to store the address of any variable irrespective of what is their data type. Okay. Now in this lecture we will see its application for array. Now if I discuss in short about the array, which is extensively discussed in other previous video lectures. So array will store a homogeneous set or list of information. It can be floating point data or it can be integer data, and since it's homogeneous, so in array they will be placed one after another, and each element will take, or each element will use same amount of memory location for their storage. So that's why if it is an integer pointer, then 4 bytes are required for each element. So if it is an integer array of 10 elements, then 4 multiplied with 10, so 40 consecutive memory location will be allocated. Now we also have seen during that array that if I call by that array name without any subscript, then it will return the base address, okay, which is similar to ampersand name of the variable within square bracket 0, which means the base address is also the starting position of the array and it is the address of the 0th element of the array. Okay. Now in pointer expression, like other variable, pointer variable can appear in expressions. What are allowed in C? In the context of array pointers, first of all, you can add an integer to a pointer, subtract an integer from a pointer, subtract one pointer from another related pointer, of course, and if P1 and P2 are both pointers to the same array, then P2 minus P1 gives the number of elements between P1 and P2. So you see the first example or first situation where by taking the subtraction I can count that what is the size of the array. So it is the size of the array when P1 will point at the 0th element and P2 will point at the end element. But if P2 will point intermediate element, then P2 minus P1 will give me the number of elements within that only, not within the array. That is, I think, trivial and you can understand. Now although it is true that P1 and P2 as a pointer will store the address of some variable, and that address can be the address of 0th position, 1 position, 2 position, 2nd position, 3rd position of the array, or in general ith position of an array. But if I take the difference, it will tell me the number of elements, because to the pointer it is implicit that what is the data type. So it will subtract. Similar to that one, we will see shortly that with some pointer, if I add an integer value, then that is similar to moving that many indexes towards the right side of the array. If I subtract, towards the left side of the array. So those things are allowed. But which is not allowed is adding two pointers, multiply or divide a pointer in an expression. Now regarding this adding two pointers or multiplication and division of pointers, you try to understand that what is the meaning of this one. As such, there is no meaning I can find. That's why corresponding to this one, no instruction is implemented in the compiler to have P1 plus P2 and then get P1, and that is you can consider one of the main primary reason that why it is not allowed. On the other hand, in order to know that between two pointers how many elements are there, subtraction is useful. Also, if I add some integer constant or some integer value with some pointer, then in an array that many number of indexes or elements I can hop. So that's why it is allowed. And when I take the difference between two pointers which will indicate two address of two elements in an array, then I mentioned that I will get the number of elements inside that array. And if I add some integer either using a variable or some constant like 1, 2, 3, 4, then those many number of indexes I can hop. And for that you need not have to mention what is the data type. Although I know that based on the data type, basically how many bytes will be reserved will vary. Here byte is transparent to me. I do not able to see that one, and that is also not required for me. But the amount actually will be traversed or amount actually will be added with it is also called as the scale factor. Okay. So in reality it is an integer value which is added or subtracted, but rather the scale factor times the value. Okay. So here you see that an integer value can be added to or subtracted from a pointer variable like this: int star p1 star p2 int ij, p1 equals to p1 plus 1, so one index will be incremented, p2 equals to p1 plus j, so j number of elements will be moved, then p2 plus plus, so increment by another, so from ith position to I plus 1 position, p2 equals to p2 minus I plus j, so I plus j will be added and then it will be subtracted. And you understand that there is an array which is not declared and shown here, but actually p1 and p2 are taking or initialize the base address of that one. That please understand and assume. Now since there is an option for subtraction, if I do subtraction of p2 minus p1, assuming or assigning p2 to one p2 to address of one in array element and p1 to the address of another array element, then p2 minus p1 will give you the number of elements inside that array. Now here if I subtract like this way, say p2 equals to p2 minus I plus j, then the final address will be decided based upon the position where p2 is pointing at, I mean which element, I mean the address of which element is stored in p2 and what is the value of I and j. That way there is every possibility that if you do not program it correctly and if you do not track it properly, then the address will go on beyond the limit of the array. It is not only for the subtraction but for addition also. When say I am doing p1 plus j, if at the position of p1, which means at the address of the index pointing by p1 plus j is goes beyond the limit of the array, then it will store some address which is not a valid array address for us. Now as you know, similar to array, there is no bound checking here also. So it is entirely your responsibility as a programmer to keep track of where you are moving. Okay. Nevertheless, this is the information regarding the data type and scale factor. For character it's 1, for integer 4, for float 4, for double 8, and I believe you are aware about this one since you were introduced with the data type. This is the number of bytes required to store one character variable. one integer variable, one floating point variable, and one double variable. If P1 is an integer pointer, then P1 plus plus will increment to the value of P1 by 4. Okay. So it will not increment by just what is the value or address of the P1 to the next byte. It will increment to the next element. Even if it is not array, if it is a single say variable, then also it will be incremented by that amount. The scale factor indicates the number of bytes used to store a value of that array. So the address of the next element of that type can only be at the current pointer value plus size of data. The exact scale factor may vary from one machine to another, that you understand, because in some system integer may be represented by 2 bytes, in some system integer may be represented by 4 bytes. Now if there is a difference and you are interested to know, then doing the pointer operation you cannot get that one. So in order to get that one, you have to use size of operator, which gives the size of the data type, and its syntax is size of data type. If you mention that one, then it will tell you in this system what is the value. Now this program is this size of is compatible, and you can take this one from one system to another system also. And it is also a good thing to check, although I believe nowadays almost all the systems supports similar data type and similar storage, but if there is any variation, you will get that information from here. Okay. Now the pointer arithmetic and element size. I declare two variables, pointer variables, double star p star q. The expression p plus 1 yields the correct machine address for the next variable of that type that I mentioned. Other valid pointer expression like p plus I plus plus p, p plus equals to I. So for this p plus equals to I, you can understand that p equals to p plus I is similar to p plus equals to I. And this p plus I, this is not just a unique statement. Definitely you have to assign this one to some other pointer variable, something like q equals to p plus I. Okay. P minus q, it will tell the number of array elements between p and q. Since a pointer is just a memory address, we can add to it to traverse an array that I mentioned. Now p plus 1 returns a pointer to the next array element if I assume there is an array and p is pointing to some array element. In that way, by this time, I guess I can tell you that star p will be the content of that element. If I do star p within parenthesis plus 1, this will actually add 1 with the content of the memory location whose address is stored in p. Now the star p plus plus will do the same thing, because star p is with the higher precedence compared to this plus plus. So it will go to the content of p and then it will increment that one. Okay. Now regarding this one, p plus 1, it will add 1, then it will go to that content. Okay. Now you can check what will happen with this one, star within parenthesis p plus plus. This I am not going to tell you, this is for you. And also I insist and encourage that you please implement all 4 of these and check how it differs or how it varies. For that, only thing you need to do, you declare one variable, array variable, and then declare another integer pointer, say p, you take the base address or address of some position and perform this one. So if you perform, then you will see that what is the difference, and in order to see the difference you should have different numbers as all the numbers or all the elements as distinct one. In these two steps I am showing you the equivalence of the statement x equals to star p plus plus. This is equivalent to x equals to star p and p equals to p plus 1. Okay, then x equals to star p within parenthesis plus plus, x equals to star p equals to star p plus 1. Okay, so this you can see that based upon the precedence which one is taking, and if it is not and you can also see whether it is p plus plus or star p which is taking the precedence. Okay, you can also test that whether this equivalence is correct or not. Okay, so again I am telling that I am not telling you that all are correct. So this question mark is for you. You have to test this and you have to understand what is going on. Okay, anyway, what if we have an array of large structure or objects? C takes care of it. In reality, p plus 1 does not add 1 to the memory address, it adds the size of the array element. Okay, so in this pointer arithmetic all are allowed, but their meaning will be different. So again I insist you to do a homework on this, whether these four are equivalent or not. If not, then whether you can group them into 2, 3 or all 4 of them are distinct. Also you test whether this is equivalent to this one or not, and this is equivalent to this one or not, this statement or not. Okay. Now another important and interesting application of this pointer is we can walk through the array using the pointer. How? Here is a simple program. This program takes 3 arguments, int star from, int star to, int n. So this is a pointer, this is also a pointer. For the timing, please assume in the next lecture we will elaborate more on this one, passing array pointer to function. So this from and to is basically the array pointer. Okay, and n is the size. Now I am inside this for loop. What I am doing, I am copying the content of this array from to. As you know by this time that by assigning 2 arrays I cannot copy their values. So I have to do it element wise by writing some simple loop like this. Here I am copying the content of the array whose base address is passed to from variable, pointer variable, to pointer variable, and I am incrementing that one and I am doing that one. C automatically adjusts the pointer by the right amount each time, that is 1 byte by a character, 4 bytes for an integer, etc. Okay. So another example, C knows the size of the thing, I mean the element a pointer points to. Every addition or subtraction moves that by many byte. So following are equivalent: int get, int array square bracket. I am passing the array to the variable to the function int n, and then I am returning array n. So nth element of the array I am returning, or array plus n, the address of the nth element, star, which means again the nth element of the array I am returning. So this statement and this statement, they are equivalent. more on pointer arithmetic. If the array size is n, 1 to access, 0 to n minus 1. Test for exit by comparing to address one element past the array. So here first I am declaring the array AR10, then star P, star Q, sum 0, P equals to AR, Q equals to ampersand AR10. Okay, so this AR10 is basically the element 11th element, because subscript is 10 and C starts from 0, and this ampersand indicates the address of that element. Now while P not equals to Q, then sum plus equals to star P plus plus. Okay, in order to do that one, my intention is actually to do that sum equals to sum plus star P, P equals to P plus 1. So please check, is this legal or not? I mean, whether I can do that one or not. If not, what is the mistake? You please identify. One clue might be that how long it will go. So you check on that one, and then whether it is adding the values or not. While doing that one, do not forget to initialize this array, otherwise this array will take some uninitialized value which we can call as the garbage. Now C defines that one element past end of array must be a valid address, that is not cause and bus error or address error, which generally is denoted to you as segmentation fault, and it is very difficult to debug if there is a segmentation fault. Okay. Now here is an example which I demonstrated also to you, but again for your to refresh your memory, that size of int using the size of operator, I am printing how many bytes are required for an integer variable, floating point, double and character variable, and here I am printing how many bytes are required to store an integer pointer, floating point pointer, double pointer and character pointer. Now you see that for integer and float it takes 4 bytes to store, for double it takes 8 bytes to store, for character 1, but when it is about the address, so it is 4 bytes corresponding to each variable. So that's why I mentioned that a pointer variable will be stored in 4 bytes as an unsigned integer, irrespective of the data type of the variable for which the address is being stored. Note that pointer takes 4 bytes to store independent of the type it points to. However, this can vary between machines. Output of the same program on a server may change, and when it is changing, you see this 4 for integer and float, double is 8, character is 1. So on a server, if it is 8, which means the address requires 8 bytes to store. But my point regarding that, it will take the same amount of memory to store the address of any variable irrespective of the data type of the variable is true. In most of the desktop, laptop, it is 4 byte the address, but if it is 8 byte, then it is 8 byte for integer, character, float, double, for everything, but it will be same. Always use size of to get the correct size. Okay. Should also print pointers using %p instead of %u, as we have used so far for easy comparison. So here is another example. So where using %p, if we try to print, then output on a server machine is looking like this. So no need to be too much panicked with this one, because this p indicates address which is in, as you located that FF is there, which means it is hexadecimal representation, it is address. Okay, so this is the notation which indicates that next the representation is coming in hexadecimal format. This is a representation in unsigned int, but the point which should be noted is that the number of bytes it will take will be same for all the variables. Okay. So pointers and array. When an array is declared, the compiler allocates sufficient amount of storage to contain all the elements of the array in contiguous memory locations. The base address is the location of the first element, that is the index 0 of the array. The compiler also defines the array name as a constant pointer to the first element. Now example, you can consider like this: if int x5 is declared and assigned at the same time, then the assignment can be done within opening and closing braces separated by comma. Now suppose that each integer requires 4 bytes. Compiler allocates a contiguous storage of size 5 cross 4, that is 20 byte. Now if I assume, without any loss of generality, that the starting or base address of the storage is 2500, then x0 through x4 will be stored in the address 2500 plus 4, 2504 plus 4, 2508 plus 4, 2512 plus 4, 2516. And the value, if I assume, that is stored in this location, and yes, it will be stored in that location, and since the value is initialized as 1 2 3 4 5, so 1 2 3 4 5 will be stored here. Now the array name x is the starting address of the array. Both x and ampersand x0 have the value 2500. So for the array, I can access the base address by writing the name of the variable or writing ampersand followed by the first element, that is x0. Now x is a constant pointer, so cannot be changed. So if you try to change, then there will be an illegal operation, because if it is changed, then I will lost my information regarding the array. But if it is required to change, then what you need to do, that you copy it to some variable and then you keep on changing the copied variable, but do not alter the name of the array and its address or its base location. Okay. Now if int star p is declared, then p equals to x and p equals to ampersand x0 are equivalent. That is what we discussed. We can access successive values of x by using p plus plus or p minus minus to move from one element to another. So relationship between p and x is very clear to you, I believe now, because the base address or the starting position of the array, by assigning x, only x, to p or ampersand x0 to p, will assign actually 2500, that is the starting address location for array element x, array x, the total array x, to p. Then p plus 1 is the address for ampersand x1, p plus 2 is the address for the x2, p plus 3 is the address for x3, p plus 4 is the address of x4. Please note that I introduced with you the scale factor, where you did not have to mention the number of bytes required to multiply with that one in order to move from one element to another. If you do plus 1 plus 2, then it will take care about that what is the data type, and accordingly it will move on. Okay. Now in general, star p plus I gives the value of xi. Now also you note one thing, that there is another alternative way, of accessing ith element from the array x. One is xi, another is within parenthesis p plus I, then star. So you first add I with p, go to that location and then access that memory location. Now C knows the type of each element in array x, so knows how many bytes to move the pointer to get the next element. Okay. Now the important fact is what I mentioned you earlier, that you have to keep track of the array bounds. Okay. There is no mechanism in C which will tell you that you are going beyond the array bound. So you are copying say base address and then you are adding that one plus plus or adding some other integer value like I, j or any other value, or you are subtracting, so moving right side or left side from the array. But by this way, whether you are going outside of the array or not, that you have to keep track as a programmer. Okay, an array in C does not know its own length and bounds not checked. So the consequence is, while traversing the elements of an array either using square bracket or pointer arithmetic, you can accidentally access off the end of the array. Okay, access more elements than what is there in the array. We must pass the array and its size to a function which is going to traverse it, or there should be some way of knowing the end based on the values. For example, a negative value ending a string or a positive value. So kind of the situation what we have discussed in the context of iteration and loop, that when the loop is indefinite in nature, not infinite, indefinite in nature, then there will be some known termination, say some negative number. By this time you know the end of the character for a string is /0 or /n, but when it is stored it is the /0. So if that kind of situation is there, then by checking that you can tell that whether array bound is reached or not. Otherwise you have to pass the size of the array along with the address. But then also, if you are adding some number which is not just plus plus or plus 1, then you may skip out of that end of the character like /0. So it is entirely your responsibility, and always keep this in your mind. Now accessing arrays out of bound can cause segmentation fault, and this will appear so when you will run or execute your program with or without any output. I mean, yes, it will not give any other error message, or say it will execute some part of your program, then it will write segmentation fault, or it will write just segmentation fault. Okay. Now it is very difficult to debug segmentation fault because it does not contain only one single type of fault. A number of faults mostly occur due to this illegal access to the memory or some bus error will occur. Okay. So always be careful when traversing arrays in program. Now here I am extending the pointer concept for user defined data type, which is structure. Okay. So far I discussed in the context of basic data type like character, integer, double, float. Now I am extending for user defined data type, which is structure. You know how to define a structure, and this is the simple example of structure where only two member variables are there, first and last, and name of the structure is name itself. So you can, okay, from here you can guess and infer that it will store the name of some person, let us assume. And then I am declaring one pointer variable for the structure, similar way. So the data type, which is struct name, if I use type def, then only that name will come, otherwise struct name is my data type, and start p. Then p will store the address of the variable whose data type is struct name. Okay. So here you can see this is the structure definition. This is not the any variable declaration of type struct name, that will come after, or I have to declare that separately. But here it is the pointer variable declaration of data type struct name. Now p is a pointer which can store the address of a struct name type variable. Okay. Now again the question is, what will be the memory requirement for star p? I mean that how much memory it needs to store in order to store the address of one structure variable. Okay. Now pointers to structure. Pointer variable can be defined to store address of structure variable. Here is another example: struct student, int roll, character department code, float CGPA, and struct student star p. Just like other pointers, P does not point to anything by itself after declaration. Need to assign the address of a structure to P. Can use ampersand operator on a struct student type variable. For example, struct student X, now here it is the struct student variable. So this is a variable whose data type is struct student, and this is a variable, pointer variable, whose data type is struct student. Now in scanf, %d, %s, %f, so what I am doing, ampersand x dot roll, x dot department code, x dot cgpa I am doing, and p equals to ampersand x. Okay, so I believe there is a, okay, no, so department code is an array, so that's why I did not have to give that ampersand. So the base address is taking here. So p equals to ampersand x. So it is storing the address of the structure variable x, that p. If I store that one, then I will introduce one more operator, that is the arrow operator. Okay, so this arrow operator is what? So once I am having a structure variable declaration like this, here you see the name of the structure is struct student, variable is int roll, character department code 25, float cgpa. Okay, so inside this structure is roll, department code, and cgpa. The name of the variable for a structure is x, and pointer to the pointer to x is star p. So in order to access roll, x dot roll, to access department code, x dot department code, to access cgpa, x dot cgpa. That's why if I write, say, p equals to ampersand x, so in order to access an element like previously, so what I have to do, star p, then star p will give me the address of basically that, so star p will allow me to go to the address of x, then from there I can access this roll, department code, cgpa. So like that way, so I can access star p within parentheses to have this with the higher precedence, dot roll, star p dot department code, star p dot cgpa. Now this star p within quote and then dot can be replaced by this arrow operator. So p, this is an arrow roll, p arrow department code, p arrow cgpa. So this p arrow cgpa is equivalent to star p within parentheses dot cgpa. This star p within parentheses dot roll is equivalent to p arrow roll. Star p within parentheses dot department code is equivalent to p arrow department code. So this is the arrow operator. Now you can try this out by writing a small piece of program where as an input you can give some roll number, cgpa, and department code, and then you can access by these two statements where you are using star p, another you are using this arrow operator. Okay, recall that the name of an array is the address of its 0th element. You agree with me? So if I define, if I declare one array like int ar within square bracket 10, then ar is same as ampersand ar0. Both will indicate the address of the array. In this case, the address means base address. Also true for the names of arrays of structure variables. So if there is an array of structures like this, struct student class 100, so you can do this one, and there is star ptr. Then if I write star ptr equals to class, then it will indicate the ampersand class 0 or the starting position of the class 0 array structure. So the name class represents the array and the address of the 0th element of the structure array. ptr is a pointer to data object of the type struct student. The assignment ptr equals to class will assign the address of class 0 to ptr. Now ptr arrow roll is same as class 0 dot roll, same for other members. When the pointer ptr is incremented by 1, the value of ptr is actually increased by size of struct of student. Now you please note, this is also similar to the previous one. So last time If say it is pointer plus plus, then I mentioned it will increment to the next element. In an array of integers, it will go to the next integer element. In an array of floating point numbers, it will go to the next floating point number. In an array of characters, it will go to the next character. Similar to that, if it is the array of structures, then ptr plus plus, where ptr is a pointer to that particular structure element, then it will go to the next element of that structure. And next element means how much advancement will happen. It is the struct student type. So that you can get by using that size of operator, that within size of then struct student, the data type you mentioned, similar to previously what I have discussed. It is made to point to the next record. Note that size of operator can be applied on any data type. So a warning, when using structure pointers, be careful of operator precedence. That is very important. So member operator dot has higher precedence than star. So this pointer right arrow role and star pointer within parenthesis dot role mean the same thing. However, star ptr dot role will lead to error. So this is very simple but important thing. Simple in the sense, you know that if there are more than one operator, then definitely the operator with the higher precedence will be executed first. Like you know, if there is a plus b multiplied with c, then b multiplied with c will occur will be evaluated first, then it will be added with a. It is not like, since I am moving from left to right, so a plus b will be evaluated first, then it will be multiplied with c, because you know this multiplication is of the higher precedence than this addition. In this case also, the dot has the higher precedence than star. So if my logic says that I have to go to that address location where the structure element is, then access that role, then I have to put it inside the parenthesis, or I have to use arrow operator. But you should not write star ptr. So from that point of view, my personal suggestion is better to use arrow operator, since there is only one operator, there is no confusion. But if there are two operators, then what is the whether I will give the parenthesis or I should not give the parenthesis, or what will be the meaning of this one is not very much clear to me. Maybe if that is the case, that whether within parenthesis or without parenthesis is the thing I need to do, so in that case it is better not to go for this one, just go for this arrow operator. The operator arrow enjoys the highest priority among operators. So plus plus ptr, this pointer, so first it will go to this, then it will be incremented. But if you write this plus plus pointer arrow this, then it will be incremented first, then it will go to roll. Now this is simple, that you understand. Its precedence is high, that's why it will be executed and then it will be incremented. But in this case, you are changing the precedence by giving a parenthesis, and that's why within the parenthesis will be executed first, followed by the next. Now arrays within structures, if there is, then absolutely no problem. So what I can do, this is the index for the array of structures and this is the index for the array of marks inside one structure element. Okay, so I and j are used. Now for that also there is no confusion. You may recall that the name of the array stands for the address of its 0th element. So in this case also, although it is here, so no confusion, you can have that same thing here also. Okay. So this is the utility of the arrow operator. And that's it for today. So one more thing is remaining that we will discuss in our next class is the functions and what is the application of the function in the what is the application of the pointer in the context of the function. Specifically, we will discuss that call by reference and how we can modify multiple values from the function. All those things we will discuss in the next video lecture. Thank you.